Hello students, welcome back to this lecture. One previous year questions, one real numbers. Okay, so in our previous lecture we have discussed some previous year questions, one real numbers. So in this lecture we'll continue remaining questions, one PYQ of real numbers. Okay, so let's get started. In our previous lecture we have discussed question number 1 to question number 7. So here from question number 8 we'll discuss. Okay, so here in this question we have asked about these numbers. Okay, so here you can see, you can simplify this number 5 minus 3 times root 5 plus root 5. Okay, and this is equal to 5 minus root 5 times 3 minus 1, and this is equal to 5 minus 2 times root 5. Okay, and here our claim is 5 minus 2 root 5 is irrational number. Okay, so now proof. First here we'll prove by method of contradiction. So first let us assume 5 minus 2 root 5 is rational number. Okay, this is rational number. Then therefore we can find A and B where B not equal to 0, and we can write 5 minus 2 root 5, this is equal to A over B. Okay, since 5 minus 2 root 5 is rational number. Okay, so 5 minus 2 times root 5, this is equal to A over B. So if A and B have common factors other than 1, then we can divide by its common factor, then we'll get two numbers that are co-prime. Okay, so here we suppose A and B are co-prime. That means A and B have no other common factors other than 1. Okay, so now we can rearrange this equation. So if we rearrange this equation, then we'll get minus 2 times root 5, this is equal to A over B minus 5. That is root 5, this is equal to 1 by 2 times 5 minus A over B. Okay, so root 5, this is equal to 1 over 2 times 5 minus A over B. And here A, B are integers, 5 is also integers. So 5 minus A by B, this is rational number, and 1 by 2 times 5 minus A over B, this is also rational number. So this number rational number. Okay, so therefore it implies root 5 is also rational number. Okay, so root 5 is also rational number, but in our previous lecture we have proved root 5 is irrational number. So this contradicts the fact that root 5 is irrational number. Okay, so this contradicts the fact that root 5 is irrational number. So these contradictions has arisen since our assumptions 5 minus 2 root 5 is rational number is wrong. Okay, so therefore 5 minus 2 root 5 is irrational number. So the number 5 minus this is an irrational number. So here option C is correct option. Okay, students. So option C is correct option. So basically we first simplify this number, and this number after simplify we get 5 minus 2 times root 5, and by method of contradiction we assume this is rational number, and we can write this number as A over B, where we suppose A and B are co-prime. Then we can rewrite this equation and we'll get this equation. Okay, root 5 is equal to 1 by 2 times 5 minus A over B, and in right hand side this number is rational number, so therefore this root 5 is also rational number. Okay, but we know root 5 is irrational number, so this contradicts the fact that root 5 is irrational number. So therefore this contradicts our assumptions. Okay, so 5 minus 2 times root 5 is basically irrational number. So this number is an irrational number. Now let us move to next question. So in next question, here the ratio of HCF to LCM of the least composite numbers and the least prime number is what? Okay, so here I have given some ratio. Okay, HCF to LCM of the least composite numbers and the least prime numbers. So what is the least composite numbers? What is the least composite numbers? So you know the least composite number is 4. Okay, the least composite number is 4 and the least prime number is 2. Okay, and if we take HCF of 2 comma 4, this is basically equal to the highest common factor is here, the highest common factor is 2. Okay, so this is equal to 2, and LCM of 2 comma 4, this is equal to the product of highest power of the prime factors numbers. So here the highest product of highest power of the prime factors is 4. Okay, so this is equal to 4. So HCF of 2 and 4, this is equal to 2, and LCM of 2 and 4, this is equal to 4. So for finding ratio, we take this ratio HCF of 2 comma 4 divided by LCM of 2 comma 4. That is basically equal to 2 over 4, and this is equal to 1 by 2. Okay, so therefore HCF of 2 comma 4 is to LCM of 2 comma 4, this is equal to 1:2. Okay, so HCF of 2 comma 4 is to LCM of 2 comma 4 is equal to 1:2. That is the HCF and the LCM of least composite numbers and the least prime numbers is 1:2. Okay, so here 1:2. So here you can see option. So the ratio of HCF to LCM of the least composite numbers and the least prime numbers is 1:2. Okay, 1:2. Okay, 1:2. So here option A correct option. So remaining options B, C and D are incorrect options. So here only correct option is option number A. Let's move to next number question. So this is question number 10. Okay, and given that root 3 is an irrational number, and here we have to show that 5 plus 2 times root 3 is an irrational number. Okay, so we have given root 3 is irrational number, and here basically we have to show 5 plus 2 times root 3 is an irrational number. Okay, so we'll prove by method of contradiction. So first we let 5 plus 2 times root 3. 5 plus 2 times root 3 be a rational number. Okay, and then 5 plus 2 times root 3 can be written as P over Q, since any rational number can be expressed as a fraction P over Q, where P, Q are integers and q not equal to 0. Okay, so since we let 5 plus 2 times root 3 be a rational number, so 5 plus 2 times root 3 can be written as p over q, where pq are co-prime integers. Then we can rearrange this equation. Okay, 5 plus 2 times root 3, this is equal to p by q. Okay, and this implies 2 times root 3, this is equal to p over q minus 5, and this is equal to p minus 5q by q. Okay, and if we divide this equation by 2, then we'll get it implies root 3, this is equal to p minus 5q by 2q, and in right hand side we have p minus 5q by 2q, and here p, q are integers. Okay, and q not equal to 0, so this fraction p minus 5q by 2q is basically rational, as p and q are integers. And in left hand side we have root 3. Given in this question, root 3 is irrational number, but from this equation root 3 is equal to p minus 5q by 2q. Here it implies root 3 is rational number. Okay, since this number p minus 5q by 2q is rational number. Okay, so root 3 is rational number, so but it is given that root 3 is irrational number. Okay, so here left hand side is irrational number and right hand side is rational number. Okay, so this contradicts our assumptions that 5 plus 2 times root 3 is a rational number. Okay, so therefore 5 plus 2 times root 3 is an irrational number. Okay, so 5 plus 2 times root 3 is an irrational number. So proved. That actually we have to prove. Okay, so 5 plus 2 times root 3 is an irrational number, where root 3 is irrational number given. Now let us see next one. Okay, so an army contingent of 612 members is to march behind an army band of 48 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay, so we have to find the maximum number of columns in which they can march. Okay, so let us see solution. So for maximum number of columns, we need to find the highest common factor, that is HCF of 6, 1, 2 and 48. Okay, so for getting maximum number of columns, here we need to find HCF of 6, 1, 2 and 48. Okay, so we can find HCF of 6, 1, 2 and 48 by using Euclid division algorithm. Okay, so here 6, 1, 2 can be written as 48 times 12 plus 36. Okay, so if we multiply 48 with 12, then we'll get 6, 1, 2 with leaving remainder 36. Okay, so by Euclid division algorithm, 6, 1, 2 can be written as 48 times 12 plus 36, and then 48 can be written as 36 times 1 plus 12. Okay, and then 36 can be written as 12 times 3 plus 0. Okay, so 36 can be written as 12 into 3 plus 6 plus 0. Okay, so here HCF of 6, 1, 2 and 48 is equal to 12. So we could able to find HCF of 6, 1, 2 and 48, that is equal to 12. So the maximum number of columns they can march, in which they can march, is 12. Okay, so this is our answer. Now let us move to question number 11. So in question number 11, we have to find HCF of 92 and 152. Okay, so we need to find HCF of these two numbers. So let us find So here we will use factorization method, prime factorization method. So first we factorize 92 as a product of its prime factor. Okay, so 92 can be written as 2 into 2 into 23. Okay, and 152 can be written as 2 into 2 into 2 into 19. And then HCF of 92, 152, that is basically the product of lowest power of the common factors in numbers. Okay, and here you can see the common factor is basically 2, and the lowest power of this common factor is 2. So HCF of 92, 152, this is equal to 2 square, that is equal to 4. Okay, so HCF of 92, 152 is equal to 4. Okay, so 4. So option A is here correct option. So now let us move to next number question. This is question number 12. So HCF of two consecutive even numbers is what? So you know 2, 4. They are two consecutive even numbers. Okay, so 2, 4. If we find HCF of 2, 4, that is basically equal to 2. Okay, and similarly, you can find HCF of two consecutive even numbers 6 and 8. Okay, that case you also find the HCF of 6 and 8, that is equal to 2. Okay, so we will solve systematically. So let numbers be 2x and 2x plus 2. So 2x can be factorized as 2 times x, and 2x plus 2 can be factorized as 2 times x plus 1. And here the common factor in both numbers is 2. Okay, and the lowest power is 1. So the HCF of 2x, 2x plus 2 is equal to 2. Okay, so HCF of two consecutive even numbers is 2. So HCF of two consecutive even numbers is 2. So here option C is correct option. Okay, I hope you got it. So now let us move to next number question. This is question number 13. Okay, so here we have to find HCF times LCM for the numbers 50 and 20. So student, you know about this result, HCF of two numbers into LCM of two numbers, that is equal to product of these two numbers. Okay, so we have two numbers A and B. Okay, then HCF of AB into LCM of AB, this is equal to A into B. For this question, here A is basically 50 and B is equal to 20. Okay, so HCF of 50, 20 into LCM of 50, 20, this is equal to 50 into 20, and this is equal to 1000. Okay, so the HCF into LCM for the numbers 50 and 20 is 1000. So here option A is correct option. Okay, so now let us move to next question. So in this question, here we have asked, for which natural number n 6 to the power n ends with digit 0. Okay, so here we have to find for which natural number 6 to the power n ends with 0. Okay, so for x to the power n, where n belongs to natural numbers, the given numbers never ends with 0. Since if 6 to the power n, 6 to the power n where ends with 0, then in prime factorization of 6 to the power n must be must be consist there 10 numbers. Okay, so 10, there must be in there must be actually 2 and 5. So in prime factorization of 6 to the power n, there must be 2 and 5. But if we see the prime factorization of 6 to the power n, this is basically equal to 2 times 3 whole to the power n. Okay, so in prime factorization of 6 to the power n, there is no 5. Okay, there is no 5. So 6 to the power n never ends with 0. Okay, so if we see now option, so there is no natural number n for which 6 to the power n ends with digit 0. Okay, so here option D is correct option, so none. So there is no natural number n for which 6 to the power n ends with digit 0. Okay, now let us move to question number 15. So in question number 15, we have asked the exponent of 5 in the prime factorization of 3750 is what? Okay, so we need to find exponent. That means the power of the numbers 5. Okay, so first we have to factorize 3750 and then we can see the exponent of 5. Okay, so here if we factorize 3750, then you will get 3750. This is equal to 2 times 3 times 5 times 5 times 5 times 5. Okay, so you can check it. The prime factorization of 3750 is 2 times 3 times 5 times 5 times 5 times 5. Okay, and it can also be written as 2 to the power 1 times 3 to the power 1 times 5 to the power 4. Okay, so here in digit 5, the power of 5 is 4. Okay, and here in this question we have asked what is the exponent of the number 5. Okay, so in prime factorization 3750, the exponent of 5 is 4. So exponent of 5 is here 4. Okay, so the exponent of 5 in the prime factorization of 3750 is 4. Okay, so here in option B we have 4. So for this question, here correct answer is option number B. Okay, so now I stop here this lecture. Thank you very much to all of you.